Assalamualaikum warahmatullahi wabarakatuh. Hello guys, my name is Ageng Maulana Wirawan and I'm here as civil engineer. In this video, I will talk about how to calculate truss analysis using a joint method. First thing first, today I was with my group mates Aldi Alanta Kusuma and Andi Sultan Rafi. So the coverage in this video is pre-calculating in the form of calculating the stability of truss system and finding the zero force in the system of trusses. Then, we will analyze a truss system using a joint method starting from calculating the reaction on the support, calculating the force, tension or compression on each member, and describing the color diagram of a truss system. So, without any further ado, time is yours, Aldi.
Okay, hello everybody. My name is Aldi Alanta Kusuma. I will explain about stability. The general formula for stability is M equal to 2G minus R. In this formula, M is for the number of stem, G for the number of connection, and R for the number of reaction. If we use pin and roll as support, then R equal to 3. Because there are 3 reactions, for our simple plain truss, we use R equal to 3, G equal to 14, and AM equal to 25. And from the result of the above calculation is 25 equal to 25, or M equal to 2G plus R. So according to the existing regulation, if M equal to 2G plus R, so O minus R, so our simple truss is stable or non-collapsible, or we can say perfect truss. Thank you.
Thanks Aldi for the explanation. I will add a little thing maybe, because M is equal to 2G minus R, then this truss system is statically determinate. We can use the joint method to get each member force. Sometimes to increase truss system strength, the contractor adds an additional member bar. This makes truss system has a formula M is bigger than 2G minus R, which means truss system is statically indeterminate and cannot be calculated using joint method because there will be many members have unknown value. For the zero force on the truss system will be explained by Andi. Time is yours.
Zero force. In the field of engineer mechanic, a zero force member is a single truss segment in a truss which, give a specific load, is at rest. Neither is tension nor is compression. In a truss, a zero force member is often found at pin any connection with the truss where no external load is applied, and 3 or fewer truss member meet. Recognizing basic zero force members can be accomplished by analyzing the force action on an individual pin in a physical system, which include the zero force. If the pin has an external force or moment applied to it, then all of the members attached to that pin are not zero force member. Example: if two non-collinear members meet in an unloaded joint, both are zero force member. 2. If 3 members meet in an unloaded joint of which 2 are collinear, then the third member is a zero force member. Reason for zero force member in a truss system. 1. This is member contributes to the stability of the structure by providing buckling prevention for long slender member under compressive force. 2. Disease member can carry load in the event that variations are introduced in the normally external loading configuration. On this truss problem, there are three zero force at FGM, FDD, and FNE bars. Zero force does not need to be calculated because no external load are applied and three or less truss member meet.
An excellent explanation from Andi. Untung ada Andi. Next, we will discuss about Truss Analysis. Before determine the forces of each member, we have to look for the direction that works on its support. We can find it using the nature of moment, that a sigma m is equal to 0. Previously, the moment was a summary of its forces that work multiplied by a distance. You should underline it that plus minus of a moment is determined from the force direction. If it is clockwise, so it will be positive, but if it is anti-clockwise, it will be negative. So in this draw, sigma mg is 0. So 0 is equal to RAV times 180 minus 20 times 150 minus 40 times 120 and minus 40 times 90, and also minus 10 times 60. So the RAV is equal to 66.6667 kilonewton. It's same with sigma MA. Sigma MA is equal to 0, so 0 is equal to minus RGV times 180 plus 10 times 120 plus 40 times 90 plus 40 times 60 plus 20 times 30. So RGV is 43.33. Don't forget to correct the forces that work by summarizing all forces on the truss system. We will using the control with sigma v is 0. So 0 is equal to RAV plus RGV minus all the external forces that go in this truss system. If it's 0, the truss, the calculation is good and the calculation is right. But if it's not 0, so you should calculate it again, or maybe you can change the data. Next, we will determine the forces on a truss bar. To gain an external forces of each member, we have to separate each joint and analyze the free body diagram of each joint in order to get its internal forces. We should do it one by one until we get all the members. Because we already have the RAV and RGV, so we can calculate the free body diagram on point A and point G. In point A, sigma Fy is equal to 0, so 0 is equal to RAV plus FAB times sinus 83. So FAB is equal to minus 83.4757. And also for the sigma Fx is equal to 0, so 0 is equal to FAB plus FAB on the top times cosinus 53. So FAB is equal to 50.24. For the joint G, sigma Fy is equal to 0. So 0 is RGV plus RGF times sinus 83. So FGF is equal to minus 54.2562592. For the sigma Fx is equal to 0. So 0 is FGF on the bottom plus FGF on the top times cosinus 53. So FGF on the bottom is equal to 32.65. Okay, for the joint B, maybe it will be a little bit different because I want to use another equation. So in here I use the moment. So sigma moment on D point in here is equal to 0. So FCD is equal to the RGV times 30 times 3 plus 10 times 30, and it will divide it to 40. So if you see on this draw, this is the moment, and RGV will be multiplied by the distance to the D. So it will be 30 times 3. And also for the 10, it will be multiplied by the distance to the D. It will be 32. And it will be divided to 40 because FCD on the top and D is on the bottom. So the FCD will be minus 90 kilonewton. Because we already know the FCD, so we can calculate the FBC2 using sigma Fy is equal to 0. 0 is equal to FCD minus FBC. So FBC will be same with FCD. It will be minus 90. For the sigma MB is equal to 0. So FCD is equal to RGV times 30 minus 40 times 30 and divided into 40. Oh, sorry, it's not RGV, but it will be RAV. So let's take a look on the draw. So this is the point B, the moment, and it will be multiple. It's equal to RAV multiplied by the distance to the B. So it's 66 times 3 times 30 minus 40 times 30. 30 is the distance from B to the C, and divided with 40, the height of the truss. So FCD will be minus 80. For the joint D and joint E is very easy to calculate because they in the same row with BC and CD. When there are not have another bars that have horizontal forces. So DE and EF will be same with BC and CD. So it's equal to minus 90. Next is still in joint B, because we already know the most of the data. So sigma fx is equal to 0, and 0 is equal to fab times cosinus 53 minus fbc plus fbm cosinus 37. So fbm will be 46.44. For the sigma fy is equal to 0, so 0 is equal to fab times sinus 53 minus fbb minus fbm times sinus 37. So minus 66.6667, it was the RIV, is equal to fbb plus fbm times sinus 37, whereas fbm is equal to 38.7174. Okay, then we will go to joint B. So in joint B, here sigma fx is equal to 0, so 0 is equal to fab plus fbc plus fbm times cosinus 37. So fbm is equal to 37.27, as you can see here, fab, and this is fcd, so minus fab minus fcd divided by cos radians 37. So next is joint M. Here joint M, sigma fy is equal to 0, so 0 is equal to fbms times sinus 37 minus fbms times sinus 37 plus fmd times sinus 37. So fmd is 9.174. So in this equation, minus 37.27 or fbm times sinus radians 37 plus 46.44, whereas it is an fbm times sinus radians 37 divided with sinus radians 37, so it will be 9.174. Then for the sigma fx is equal to 0, so 0 is equal to minus fbm times cosinus 37 minus fbm times cosinus 37 minus fmd times cosinus 37 and minus 40. This 40 is the load, the external load, plus fmc. So fmc is equal to 19.526. Here, as you can see in here, fmd times cosinus radians 37 plus 46.44 or fbm cosinus radians 37 minus 37.27, versus it is fbm times cosinus radians 37 and minus this external load. Okay, for region D is sigma Fy equal to 0. 0 is equal to Fmd times sinus 37 plus Fdn times sinus 37 minus 40. Where is the point D or D joint in here? If you want to see it, here in the middle of the trusses. So Fdn will be 57.29. See in here, minus Fmd times sinus radians 37 plus the external load is 40 kilonewton divided with sinus radians 37, so it will be 57.29. And for the sigma fx, it will be 0 to 0 will be fcd plus fde minus fmd times cosinus 37 plus fdn times cosinus 37. So fda will be 41.57. Here fdn, oh no, here fcd, whereas it is minus 80 plus fmd cosinus 37 minus fdn cosinus 37. For the joint f, here the joint f, the sigma fx is equal to 0, so 0 is equal to ffg minus fef. Here ffg times fef plus f and f times cosinus 37. So f and f will be 11.166 here. So fda 41 minus here 32.95. So here and here we will find this one. So f and f is 11.166. For the sigma fy is equal to 0 to, so 0 is equal to ff plus f and f times sinus 37. So f and f is equal to 7.186, whereas it's from f and f times sinus 37. Okay, for the last one is joint n. Here is joint n. Joint n, the sigma fy is equal to 0, so 0 is equal to fen plus f and f sinus 37 minus fdn sinus 37 plus f and f sinus 37. Okay, so this one plus here sinus 37 and minus here sinus 37 and here and plus f and f here sinus 37 minus 10. Why minus 10? Because there is external load in here. So fdn is equal to 62.474. Okay, finally, as you can see in here, as you can see in the image or diagram below, The red line is a bar that experiences tension. Here, the tension. And the bar that experiences compression is colored by blue. If you can see the white one, the white color is a zero forces. So we have a 1, 2, 3, 3, 1, 2, 3, 3 zero forces. Okay, I think it's enough for this video. I will say sorry if my English is bad and my explanation is not really good, but I will improve myself to the future. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.